Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is product of the two numbers. The first question is 26 and 91. So we need to prime factorize. 26 is equal to 2 into 13 and 91 equal to 7 into 13. So for the HCF, we need to write the common factor, and the common factor here is 13. That is 13 here and that is 13 here. So I'll put 13 lowest power raised to 1. And for LCM, I need to write all the factors. All the factors means there's a 2, there's a 13, there's a 7. And 13 we have already written. So the LCM, when we multiply all this, you'll get 2, 3, 6, 6. Now this is a very interesting thing we're going to do. Is first we'll find the product of the numbers. Product of numbers. You know the numbers are 26 and 91. So 26 into 91, which is equal to 26 into 91 is 236. Here I made a mistake. It should be 182. So we go back here to the product of the numbers is 2366, and then we will find product of HCF and LCM. HCF into LCM. HCF is 13. LCM is 182, and the answer here is also 2366. So we here arrive at a very good result. We see that product of the numbers equal to HCF into LCM. This is a very important result that we will use many a times in other sums. Let's get on to the next one. So we have 510. Prime factorization of this will be 2 into 3 into 5 into 17. And we have 92. Prime factorization of 92 is 2 into 2 into 23. So 2 into 2, I'll erase this and write it as 2 square. Now to find HCF, I'm doing it directly. We write the common factors. Now which is common? There is 2 here and there is 2 here also. So we'll write here 2 and the lowest power. The lowest power is 1. So the HCF is 2 raised to 1. Now for the LCM, we write all the factors. So we have a 2, there is a 3, there is a 5, there is 17, 2 we have already written, and there's a 23, and the highest power. Of 2, the highest power is out here, 2 raised to 2, so we put 2 here. 3, the highest power is 1. 5, the highest power. 17, 23, highest power is 1. So here with the LCM works out as 23460. The next step, we'll find product of numbers, and the product of numbers is 510 into 92, and 510 into 92, when we multiply, you'll get 46920. Next we do find HCF into LCM. The HCF is 2 and the LCM is 23460, and this also works out to be 46920. So what have we seen? That the product of numbers, which is 46920, is also LCM into HCF. Now for the next sum, if we take 3, 3, 6 and we prime factorize, we'll get 2 into 2, 2 into 2 into 3 into 7. And this, there are 4 2s, so I can erase this up. I can write it as 2 raised to 4. I'll write this a little closer, into 3 into 7. And then when we have 54, we can write 54 as 2 into 3 into 3 into 3. 3, 3. So we erase this up and we write 3 raised to 3. Now to find the HCF, we pick up the common factors. There is 2 here and there is 2 here. There is 3 here and there is 3 here. So 2 and 3 are common. Now write the lowest power. For 2, there is 4 and 1. Lowest power is 1. For 3, 1 and 3. Lowest power is 1. So the HCF is 2 into 3 and that is 6. For the LCM, here we write all the factors. So there is 2 here, there is 3, 7, 2 we have written, 3 also we have written. And we need to write the highest power. For 2, we have 2 raised to 4 here, 2 raised to 1. So we write 2 raised to 4. For 3, we have 3 raised to 1 here, 3 raised to 3 here. So we write 3 raised to 3. And then the LCM works to be 3024. I will check the product of numbers. Product of numbers is 336 into 54, and 336 into 54 is equal to 18144. And then we find product of HCF and LCM. HCF 6, LCM 3024, and that answer also comes 18144. So when we compare, we find the numbers, product of numbers equal to product of HCF and LCM. So product of numbers equal to HCF into LCM. The HCF of 306 and 657 equal to 9. Find the LCM of 306 and 657. So here the numbers, we have 2 numbers, and the one number is 306 and the other one is 657. The HCF of the numbers is given as 9. Our question is to find the LCM. And we know the formula. Product of numbers is equal to HCF into LCM. Now the numbers are 306 and 657. So the product of the numbers will be 306 into 657. The HCF is 9, so we put 9 here. LCM we don't know, so LCM we need to find. So we have 306 into 657 over 9 equal to LCM. And the answer for the LCM is 22338. Check whether 6 raised to n can end with a digit 0 for any natural number n. To understand the sum, let us take some examples of numbers that end with 0. Like we have 30, it ends with 0. Say we have 60, it ends with 0. Or we have 170, it ends with 0. All these numbers are divisible by 10. 30 is 3 into 10. 60 is 6 into 10. 170 is 170 into 10. So here, if a number ends with 0, it is divisible by 10. Now, if it is divisible by 10, hence it will also be divisible by 2 and 5. Because here this 10 I can erase and I can put it as 2 and 5. In the next case also, if it is divisible by 10, it will also be divisible by 2 and 5. Here also is divisible by 10. It will be divisible by 2 into 5. So if it is divisible by 10, it is also divisible by 2 and 5, which means the prime factorization of that number should have 2 and 5. If it does not have 2 and 5, it will not be divisible by 10. Hence, the ending digit will not be 0. Here we have to find 6 raised to n. What will be 6 raised to n? We know 6 is 2 into 3 raised to n. So if you see 6 raised to n does not have 5, it has 2, but it does not have 5. Hence, it will not end with 0. So we can say the prime factorization of 6 raised to n does not have 5. Therefore, it will not end with digit 0. Let me explain this again. Suppose you have 6 raised to 2. It would be what? 2 into 3 raised to 2, which will be 6 raised to 2, 2 raised to 2, 3 raised to 2. No 5. It cannot end with 0. Suppose we have 6 raised to 15. It would be 2 into 3 raised to 15. 6, which is not 6, it is 2. 2 raised to 15 into 3 raised to 15. To end with 0, it needs at least 1 2 and 1 5, because that makes 10. It does not have a 2, it has a 2, it doesn't have a 5, so it cannot end with 0. Let's take more examples, like 4 raised to n. Will it end with 0? 4 is 2 raised to 2 raised to n. So this is 2 raised to 2n. The prime factors are only 2, so does not end with 0. We take another one, say 12 raised to n. Now 12 is 2 raised to 2, that is 4 into 3 raised to n. This also no 5, does not have 5, so does not end with 0. Let's take up, for example, 15 raised to n. Now 15 will be 5 into 3 raised to n. So here it does not have 2. It should have at least 1 2 and 1 5. It does not have 2, so does not end with 0. Anyone, you put 15 raised to 3, or you put 15 raised to 100, or you put 15 raised to 5, the number and the digit in the last number will never be 0. The one in the unit place, there may be any numbers here, any amount of numbers here, but the one in the unit place will never be 0. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Before we start the sum, let us see what are prime numbers and composite numbers. Now, prime numbers have only 2 factors, and the 2 factors is 1 and the number itself. Like 13. 13 has got 2 factors, 1 and the number itself, 13. 17 has got just 2 factors, 1 and the number itself. 23, prime number, 1 and the number itself. 7, prime number, 1 and the number itself. Now we'll see what are composite numbers. Composite numbers are which have more than 2 factors. More than 2 factors. Like if you take the number 10. 1 into 10, so it goes 2 factors, plus 2 into 5. So how many factors does it have? 4 factors. So 10 has 4 factors. Therefore, it is composite. If you take up 15, 1 into 15 and 5 into 3. Again, 4 factors. So it is composite. So if a number has more than 2 factors, it is composite. If it has just 2 factors, it is prime. Now let's find out if this is composite or prime. So here we have 13 and here 13. So we can take 13 common out. What remains inside is 7 into 11 plus 1. So 13, what remains in is 77 plus 1. So that is 13 into 78. So 13 into, now 78 we know is 13 into 6. So how many factors do we have here? We have 3 factors. We can have even more than this, 3 factors. Therefore, 7 into 11 into 13 plus 13 is composite. Let's get on to this next sum. So you remember that the plus is here. So I'm going to take 5 common out. So when I take 5 common out, what remains inside is 7 into 6 into 4 into 3 into 2 into 1 plus 1. So that works out as 5. Here it works out 1008 plus 1. I have multiplied all these numbers, which I get 1008. So this is now equal to 5 into 1009. So here it has got 2 factors plus the plus 1 itself and the number. So the number 765 into 3 into 2 into 1 plus 1 has 4 factors plus a number itself. It has got 5 as one factor, 009 as one factor, 1 and the number. We're not going to multiply and find out, but the number itself also is a factor. It has got 4 factors. Therefore, it is composite. If there were only 2 factors, it would be prime. There is a circular path around a sports field. Sonia takes 18 minutes to drive 1 round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So here is the circular path, and let's start with Sonia. It's given that Sonia takes 18 minutes to drive 1 round of the field. So if she starts at this point and she takes an entire round like this, for 1 round she would have taken 18 minutes. Now she goes on to the next round. It will be 18 plus 18. So she would have completed her second round in 36 minutes. Now suppose she goes yet for another round. The third round would be 54 minutes. Now let's see what happens to Ravi. Along the same path. I've drawn it separately because they're 2 different people, but they're going along the same path. He takes 12 minutes. He goes a little faster. So for the first round, he'll go right round like this. He'll come here after 12 minutes. So 1 round he will complete after 12 minutes. So now he comes on to the second round. For the second round now here, he will take another 12 plus 12. It will be 24 minutes. Now for the third round, he goes third round again round, and now it will be 36 minutes. So have you seen now, this is 36 and this is 36. So after 36 minutes, they will meet at one point. After 36 minutes, Sonia will be at this point after having completed 2 rounds. And after 36 minutes, Ravi will be at this point after having completed 3 rounds. So they will meet after 36 minutes. Basically what we have done, we have taken the LCM of 18 and 12. We know 18 is 3 raised to 2 into 9 and 12 is 2 raised to 2 into 3. And to find the LCM, we take all the factors, that is 2. This is wrong here. I should write 2 into, here it should be 2, right? We'll take all the factors, that is 2 into 3 and the highest power. So 2 raised to 2, 3 raised to 2. That is 4 into 9 and 36. So they will meet after 36 minutes because at 36 minutes both of them will be at this point. It is the same circle. Let me explain it again. So here Sonia starts. She takes one round. She comes here. 18. After 36 she will be here. At 36 minutes she will be here. Then comes Ravi. Ravi takes one round. And then second round. And third round. After that at 36 he is again here. So they will meet after 36 minutes.